Hi students, in this class we are going to see a few important topics: instantaneous axis of rotation and a pure rolling. What is a pure rolling and what is instantaneous axis of rotation? Axis of rotation, let's say this is a rod. Let's take this is a rod. It is fixed here. It is moving with angular velocity omega. So this becomes an axis of rotation. Axis of rotation is about the point all the particles are doing. See, now I am taking another, say 1, 2 and 3. How this particle move? The particle move in a circular motion. The first particle and the second particle and the third one, they all move in a circular path. If you see carefully, and the distance between them always remains as it is, like how these are rigid bodies, right? The distance between the 2 points never changed. Okay, so this is how this is called axis of rotation. So one end is fixed in this case. Sir, what about if one end is not fixed? What to do in this case? Say there is a body is rotating with angular velocity omega. About any one of the points at particular instant. Say it will be clear with say take the body, same body will take. It is rotating with angular velocity omega. Now if we see at particular an instant, A point may do circular motion about a particular point, okay, and point A, B, C point also may do the circular motion about origin O, okay. The C also may do circular motion about O. Then if all the particles are doing circular motion about O, then at particular instant, okay, this point O become instantaneous axis of rotation. At particular instant, this point O become an axis, okay. Say it will be clear when we discuss about or pure rolling. When rolling starts, it will be you can understand this clearly. Let me explain what are the few characteristics of instantaneous axis of rotation. Instantaneous axis of rotation can be it's a point, understand, about which all the particles of body are doing circular motion. When all the particles of body are moving circular motion, then it is called instantaneous axis motion at that instant. I forgot, at that instant, this is important. At that instant, at particular instant, all the particles should revolve around a point. That point becomes instantaneous axis of rotation. Instantaneous axis of that point, IAOR, can be within the body or outside the body also. So the point can be within the body and outside the body. Say we considered a rolling point, it's moving with angular velocity omega. The instantaneous axis of rotation can be inside the body. This is the body we are considering. It can be inside it or it can be away, outside the body also. Need not be restricted, okay. And the third and most important point, all velocity vectors makes an angle 90 degrees with position to position of IA over. All velocity vectors makes an angle 90 degrees with the instantaneous axis of rotation. See, in this case, let's do in very simplest way. Okay, now I am considering this body is moving with angular velocity omega, and say this is VA and this is another particle VB. Okay, these are the points, right? All the points, if I consider this point P as an instantaneous axis of rotation, if I draw a line from this is a point A, point B, if I draw a line from VA to P, here how much would be angle? 90. If I draw from here to here also, how much would be angle? 90. So if you draw this diagram as per our diagram, these are not making 90 degrees angle. So these are not, this point P is not a instantaneous axis of rotation. Let's draw in a proper way. Now let's draw 90 degrees from A, velocity vector, and 90 degrees vector. Okay, this is making sense, like there is a 90 degrees. And B, from B also draw 90 degrees. Okay, I'll extend a little bit. If you see carefully, this is making 90 degrees, this is also making 90 degrees at a point P. Now if you see carefully, this point P becomes instantaneous axis of rotation. Now is it within the body? No, it is outside the body. You understood this part? Sir, you may ask a question, sir, why it will be making 90 degrees angle? If you see circular motion, in a circular motion, velocity, it would be velocity V, and this is R. Omega will be V is equal to R omega, right? What is the angle between R and V? 90 degrees. Similarly, if you see carefully, and if you rotate this body, and I'll show you. Wait a minute. Okay, now this is the same diagram. Now I am rotating it. You just see. Now about this body A, point A, how it is moving? 90 degrees, velocity A, and here is an angle 90 degrees. It's like a circular motion. That is B, it is making circular motion, and all the particles are moving circularly. This is actually the meaning of rotation motion. And instantaneous axis is, this is about this point P, they're revolving like a circle, so in a circular path. That's why V is equal to R omega. Okay, V is equal to R omega. I'll tell you this one more point also, it will be clear. Say let's take the distance from here to here as A, and from here to here as B, and angular velocity omega is same or different in all the cases? Omega is same, so VA is equal to A into omega, first expression, and VB is equal to B into omega, expression 2. Now omega is same, VA by A is equal to VB by B in the both cases. Okay, VB by B. I will explain it the problem in the next case, but this is the theory behind it. Okay, shall we go to the next part? Okay. Now this is the instantaneous axis of rotation. In the instantaneous axis of rotation, there are two special cases. First case is velocity of any point and angular velocity given, are given. The problems are two types basically. Velocity of any point and angular velocity are given. Say This is a body, point P. Velocity is given as Vp. Its angular velocity is given omega. Now our question is find position of instantaneous axis of rotation, IAOR. What is the first step where IAOR will be? We don't know whether it can be inside or outside, but one important point is it is perpendicular to velocity vector. Okay, take this distance as x. Consider this distance as x. Vp is equal to x into omega. Then x is equal to Vp by omega. That's all. You got the value. Vp is known, omega is known. Okay. Next, second case, and velocities of any 2 points are given. Velocities of any 2 points are given, and you need to find position of instantaneous axis of rotation. How to do it? In this, there are two cases. Wait, no? Two cases. The first one is, let's simplify this question. Okay, now this is VA and other particle VB. I told you this method to solve. First we need to draw perpendicular from each point, each velocity vector, and perpendicular from each velocity vector. So this point where they coincide, that point P becomes the coincident point. The point B becomes instantaneous axis of rotation. Okay, instantaneous axis of rotation. I explained this already. A and B are there. 2 points, VA by A is equal to VB by B, which is equal to omega. And even if you know distance between these two, say r, it is also equal to omega is also equal to VA minus VB, and velocity should be perpendicular, right? No, it's not VA minus VB. Don't write this, or else it will be complicated. VA and VB, and because we should draw a line in the first video, and we should resolve into perpendicular and parallel components, and like that we should do. As of now, we just leave it. And this is the first case. VA by A is equal to VB by B, and we can get the values of A and B, right? Next, we'll see another case. 2 points are moving parallel. Okay, it's not the first case. Parallel to each other. Let's consider 2 points A and B, and the velocity of A is V1 and the B also in the same direction, V2. And where would be the instantaneous axis of rotation? If we consider three regions are possible: region 1, region 2 and region 3. Okay, 3 regions are possible. Whose velocity is more? V1 is greater than V2. Okay, V1 is greater than V2. Let me draw a small length. Okay, V1, V2. In this case, if it is in this part, if it is here, angular velocity should do rotation motion, right? Let's draw how it will be. It does circular motion like this, and if you see carefully, this does circular motion in this direction because the tangent But according to definition of instantaneous axis of rotation, all the bodies should do circular motion in the same direction, not in opposite directions. So option 1, position 1 is not possible. Okay, position 1 is not possible. Let's see what about position 2. Right, let's say this is a point, and here is another one. Here is a distance A, here is a distance B. Okay, this is most likely like this, if this is a point P, they are doing rotation motion. This is also doing in this way, and this is also doing in this way. Okay, and if we consider like that, omega is equal to V is equal to R omega, omega is equal to V by R. Okay, V by R, and if we see V1 by A and V2 by P. Okay, omega should be same, and V1 value is greater than V2. V1 is greater than V2, A is less than B. V1, see clearly, V1 is greater than V2 and A is greater than B. Sorry, A is less than B. A is less than B. If you see carefully, this is not possible. It cannot be equal. If you have any doubts, take numericals and try to solve it. This case is not possible. And let's see the third case. In the third case, wait a minute, I'm erasing everything. In the third case, V1, V2. If you draw a normal from here to here, and from here to here, let's take the distance as A, and here to here the distance would be B, and omega is equal to V2 by B, which is also equal to V1 by A. Okay, V1, V2 is more and B is also more, and V1 is less, A is also less. This proportionality can be equated. That is why we can make instantaneous axis of rotation at the point 3, because it depends on angular velocity omega. Listen again, you may get a doubt here. Omega is equal to V by R. V is equal to R omega, omega is equal to V by A. V2 V1 relation is equal to V2 is greater than V1. Here B is greater than A. This relation can be equated. V2 by B is equal to V1 by A. This is possible. If you take numerical, you will understand clearly. Let's see the problems now. Okay, first case, find instantaneous center of rotation for a rod of length L, and A moves with the velocity Va is equal to Vi cap, and it rotates with the angular velocity omega is equal to minus. Carefully you just see omega is equal to, it's rotating in this direction. Simple, take point A, its velocity V is known, take any position, let's take this is a distance, this is a point P, and omega is equal to, what is the formula? V by A. V and omega is equal to, what is the omega? V by 2L is equal to V by A. V gets cancelled, A is equal to 2L. Okay, its length is L, and at a distance, how much distance? The distance L from other end, instantaneous axis of rotation. It's simple as that. Why? It is velocity and position vector 90 degrees, remember. And what else is asked? Okay, that's all. Instantaneous axis of rotation. Let's see another question. And rod AB like a smooth wall. See, this is a question. This is theta, length L. The end is moving with the velocity V. This question we discussed in the first video. It's moving with the velocity VB, we don't know. and they are asking us what is the instantaneous position of instantaneous axis of rotation. Now to get the position of instantaneous axis of rotation, draw perpendicular from velocities. Velocity one perpendicular, there is another perpendicular, they are coinciding, bisecting at point. This point becomes instantaneous axis of rotation. This distance from here, it will be L sin theta. It will be L sin theta. L sin theta from here and L cos theta from here, it will be the distance. And to get the angular velocity, omega is equal to, and what is the formula? V is equal to R omega. Omega is equal to V by R. V by, what is the formula? It's L cos theta, and it is also equal to VB by L sin theta. And if you want to get the VB value, we can get the VB value. VB is equal to, L gets cancelled, V tan theta. Omega is, VB is equal to V tan theta. Omega already we know, V by L cos theta. L cos theta is known, V is also known. That's we did in the previous case a lot of calculation, but it's a simpler now. Now this is the example. I am also showing, this is exercise 3.2. I am solving this problem also, which moves V is equal to 2 meter per second, rotates the angular velocity, find instantaneous axis of rotation. Just as simple as that. Omega is known. Omega is equal to how much? 2 pi. Take a distance x, point of rotation, and velocity is V. V is equal to 2, and V by R, 2 by 2 pi is equal to position distance. It's equal to 1 by pi meter. This is about instantaneous axis of rotation.